force times distance can be written in the equation form this way. Work equals force times distance. Let's take a look at the units. Work, which is symbolized with a W, is measured in units of joules. Now it's important to keep in mind that any energy transferred to or from an object is work and can be measured in joules. Force is measured, symbolized with the letter F. It's measured in units of newtons. A force, remember, is any push or pull that acts on an object. How hard is something pushed or pulled is measured in newtons, and we call that force. Distance, obviously, is how far something is moved. We symbolize it with the letter D. And for purposes of this equation, if we're going to use newtons and joules, we have to measure it in meters, which we symbolize with the letter M. Let's take a look at one example of how we would solve this problem. So, it says, it takes 41 newtons to get a box to slide across the floor. How much energy does it take to push it 17.3 meters? Now, my approach to equations is always to first look for the interrogative word. What makes it a question? How. So what are we looking for? We're looking for how much energy. Remember, energy is joules. That's work. So we're looking for work in the equation. So we're going to be solving for work. Now, now let's see what we know. We know we have 41 newtons. So 41 newtons. Newtons is force. 41 newtons. Now we have, it's pushed 17.3 meters, so for distance, we'll put 17.3 meters. And we're solving for work, which is energy. So in this case, we simply have to multiply 41 times 17.3, 41 times 17.3, and what I get is 709.3. Work equals 709.3. Now that's 4 significant figures. I'm limited by the 41 to 2 significant figures, so when I round this, what I'll get is, since I'm going to keep these two, I'm going to look at that one to see how to round. Since that's 5 or more, I round this up. I'm going to round this to 710 joules, because remember, work is measured in joules. Let's look at another one. A battery contains 17,000 joules of chemical potential energy. If the battery was used to power a motor, how high could the motor lift a 56 Newton box? So, we're going to use the equation work equals force times distance. And what we need to do is we need to figure out what variables we're looking for and which ones we know. So I always start off looking for the one that I'm trying to find. I look for the questioning word. Here it is, how. And the question is, how high? I would measure height in meters. So I'm looking for distance. So in this case, I know that what I'm looking for is distance. Therefore, I need to know what the amount of energy is and how hard the object is being lifted, or at least how heavy the object is. So in this case, let's try to find these two values. So I see here that it contains 17,000 joules of energy. Joules is work. So I'm going to put 17,000 joules here, and I see that I have a weight of 56 newtons. So that's how heavy the box is. I have to apply that much force to move the box. 56 newtons is a force. So let's go ahead and put 56 newtons here. And I'm solving for distance. So I have to undo whatever's being done to distance. Distance is being multiplied by 56 newtons. So the opposite is I'm going to divide both sides by 56 newtons. And when I do this, this goes away, leaving me with just D. So D equals 17,000 divided by 56. So if we say 17,000 divided by 56, we get 3035714. We got a lot of numbers. 303.5714 equals D. Now that's way more significant figures than we have. We had to limit ourselves to 2 significant figures. Now this is going to be an interesting case because since this is a 0 and this one is a 3, it rounds to 300. Now, someone looking at this would think 300 is just one significant figure. One way of getting around that, if we wanted to, would be to write this as 3 times 10 to the 3.0 times 10 to the second meters. But that'd be kind of picky, wouldn't it?